Hi there. I just wanted to go through the problems that were on the midterm exam for the fall semester of high school chemistry uh, that I'm teaching this year. And the first question asked us to identify the lightest member of each of the following groups in the periodic table: the alkaline earth metals, the halogens, the chalcogens, and the noble gases. So here's our periodic table, and Um, within the periodic table, there are a number of groups of elements that have particular names that are mainly of historical origin, but the names are still used in the present day to describe the groups of elements. And the ones that are um, most commonly known, we've got the alkali metals, lithium, and the elements under it. And then we have the alkaline earth metals in group 2 of the periodic table. Next to those, we have the transition metals, and underneath are the inner transition metals, or the rare earth metals. And then over on the right side of the periodic table, the boron and carbon groups don't really have historical names as far as I've been able to tell, but the nitrogen group on the periodic table is sometimes called the pnictogens. The oxygen group is called the chalcogens, and the fluorine group is called the halogens. And then at the far right side of the periodic table are the noble gases, sometimes called the inert gases. So looking at these groups, we can see that among the alkaline earth metals, the lightest is beryllium. That's up the top of the group. The lightest halogen is fluorine, the lightest chalcogen is oxygen, and the lightest noble gas is helium. Okay, the next question asked us to write formulas for a couple of compounds and to indicate whether the compounds are ionic or covalent. And I'm going to bring up the periodic table again because this will be useful to us for answering this question. First compound is oxygen difluoride, and the elements in this compound are oxygen and fluorine. Those are both nonmetals, and so compounds between nonmetallic elements are covalent in nature, almost without exception. And the formula for this is clued in by the name of the compound. Oxygen difluoride would have one oxygen and two fluorines. And then lithium nitride is composed of lithium, which is a metal, and nitrogen, which is a nonmetal. And so when metals and nonmetals form compounds, those are almost always ionic. And so in order to work out the formula for such a compound, we need to figure out what the ions are that are formed from these elements. And to make that a little bit easier, I'm just going to copy the noble gases over here, just to emphasize that lithium follows helium on the periodic table. It's lithium is element 3, helium is element 2. Likewise, sodium follows neon, potassium follows argon, and so forth. And so when metals form ions, almost always what happens is that the metals will lose electrons, and they will often lose enough electrons so that they have so that their number of electrons matches the previous noble gas. So in this case, lithium will lose one electron so that its electrons match those of helium. And so in the process of losing one electron, lithium will form the +1 ion. And then among nonmetals, the pattern is sort of the opposite. Nonmetals have a tendency to gain electrons until they have an electron count that matches the noble gas that follows them. And so in the case of nitrogen, it will gain 3 electrons to form a +3 ion and achieve the electron count of neon. And so we've got a compound formed from Li plus and N3 minus, and in order to form a neutral compound, we need to have 3 times as many lithiums as we do nitrides, and so our formula will be Li3N. Okay, so moving along, the next question asked us to determine the number of protons, neutrons, and electrons in one atom or ion of each of the following. We've got beryllium 9 and tungsten 184, 4 plus. And so sort of the cartoon picture that we have in our minds when we think about an atom is it has a small massive nucleus containing positively charged protons and neutral neutrons, and then this nucleus is surrounded by electrons that are doing electron things, but they're outside the nucleus. And to work out the numbers of these particles, I'm going to bring up again our periodic table and remind ourselves of how the numbers of protons, neutrons, and electrons are related to the numbers in the nuclide notation that's given in this problem here. So the number of protons in an atom matches the atomic number, sometimes called Z, and so and then the sum of the protons and neutrons is the mass number, and that's A, and that's the number that's the prefix superscript on the nuclide notation. And then the difference between the numbers of protons and electrons is equal to the charge. And the charge is the suffix superscript in this notation. And so since protons are positive and electrons are negative, in a neutral atom you have equal numbers of protons and electrons, and so their charges cancel. When there are more electrons than protons, the charge comes out to be negative, and when there are fewer electrons than protons, the charge comes out to be positive. So in the case of these two atoms and ions that were given here, beryllium is element 4 on the periodic table. It has an atomic number of 4, and so that means that a beryllium atom has 4 protons. And then the number of neutrons in a beryllium atom, well, it depends on which isotope of beryllium it is. In this case, we are told that we're dealing with the isotope beryllium 9. 9 is the mass number, and which is the sum of the protons and neutrons in the nucleus. And so for this particular isotope of beryllium, since we have 4 protons, and protons plus neutrons add up to 9, we must have 5 neutrons. And then here, there's no charge on this atom, and so it's a neutral atom. The number of electrons equals the number of protons, and so we've got 4 electrons in this atom. For part B, tungsten is located right here. It is element 74 on the periodic table, so it has 74 protons in the nucleus. And then the mass number for this particular ion of tungsten is 184. So protons plus neutrons add up to 184. There are 74 protons, so we must have 110 neutrons. And then in this case, there is a charge, and the charge is 4 plus. Since the charge is positive, that means that there are fewer electrons than there are protons, and it's fewer by 4. And so since there are 74 protons, there are going to be 70 electrons in this ion. All right, and I think I'm going to stop this video here, and we will continue in the next part.